Hello Bobcats. In this video we will discuss basic organic compounds. Now an organic compound consists of carbon, hydrogen, and sometimes elements such as nitrogen or oxygen. So organic compounds consist of carbon, that's the most important element, carbon, hydrogen, and hydrogen is very important also, but not as important as carbon. Then sometimes other elements such as nitrogen and oxygen. But what's really important is that if you have carbon and hydrogen, you definitely have an organic compound. So we're going to do just basic nomenclature of organic compounds. Organic compounds can get very, very complicated. They're a huge part of covalent compounds. There are millions and millions of different organic compounds, but we're just going to look at the very basic. Now, in organic compounds, we do use prefixes to indicate the number of carbons. So prefixes indicate number of carbons. Okay, so that's the carbons that we're really looking at. Now, the first four prefixes are different, and then after that they revert back to the Greek prefixes we learned for binary covalent compounds. Now, so the first four we'd have meth. If you have a meth prefix, that means one carbon, like methane, which is natural gas. If you have eth, that means you have two carbons, like ethane or ethanol. If you have prop, that's three carbons, like propane or isopropyl alcohol. Anytime you see the word prop or prefix prop, you have three. Bute would mean four carbons, and so like butane is the liquid that's found in lighters. And these are the first four that are different. After that, it goes back to pent, meaning 5 carbons, hex, 6, and etc. So it goes back to the Greek prefixes. It's just the first four that are different. So let's look at what we mean here. So if I take and I have if I can use a color here that's different. Let's say I have 3 carbons. So 1, 2, 3. Now they're single bonded carbons. The thing is, carbon wants 4 bonds. It will do whatever it can to get 4 bonds. So in basic organic compounds, we call them hydrocarbons. What we do is we just have hydrogens that make up the other bonds for those carbons. So in this case, we have hydrogens. There's 1, 2, 3, 4 bonds, 1, 2, 3, 4, and so forth. So really what we're looking at for naming is the 3 carbons here. But when I count this, we have 1, 2, 3 carbons, and then 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So the formula would be C3H8. And we would name it, because there's 3 carbons, we would use prop, and then propane. Ane, this last part right here, means single bonds, carbons with single bonds. So when it ends in ane, if you have that ending, what we mean is that single bonds between carbons. And this is different. Let's say if I had a double bond over here, then this would be ene, so it would be propene. And if I had a triple bond over here, it would end in ine for propyne. But I'm just asking you guys to be familiar with the single bonded ane ending. So you have a prefix and a suffix ane for single bonded carbons. Now, there's a formula that you can use to know that you have these single bonded carbons, and that formula is, let's see, it'll be CnH2n plus 2. So if you think about it, that's C3, so that's N, and then number H is 2 times 3 plus 2 would be 8. And let's see how that works. So if I have hexane, let's look at hexane. So if I have hexane, okay, now hexane, that means we have C6, so because of the hex, so that's C6, and then how many hydrogens would I need? Well, 2 times 6 is 12 plus 2 is 14, so that'd be C6H14. That would be hexane. And let's see how that works if we actually draw out the molecule. So we'd have 1, 2, 3, 4, 5, 6 carbons, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So yes, it works. That's hexane because it has 6 carbons and single bonds between the carbons, so you would end with the suffix ane. Now, that's the basic organic compounds, which are called hydrocarbons because you have a bunch of hydrogen and carbon. But the next thing we want to look at is a functional group, and there are several different functional groups, but we're only going to look at one functional group. And so let's write this down. Functional group. And the functional group that we're going to look at is an alcohol. So alcohol functional group, and what an alcohol is that you have an OH attached to a carbon. Now, when it's an organic compound, that OH is not a hydroxide, it's actually an alcohol. And the way we name it would be, the name would end with OL for alcohols. So would end with the suffix OL. Okay? So how do we do that? So let's look at one. Let's look at butanol. So let's say 1, 2, 3, 4, and then we put the OH on there. The OH is the alcohol. Let me put all my hydrogens on here. And so what we have, we would call this 1, 2, 3, 4, so that's but, prefix, single bond, so we put an, and then all because of the alcohol, so butanol. That would be how we would name it. So each part of this word has a meaning. That's the number of carbons, single bonds between the carbons, alcohol, functional group, butanol. And if we wanted to write the formula, you can write it as C4H1, 2, 3, 4, 5, 6, 7, 8, 9, H9OH. Oops, sorry, C4H9OH. And that would be the functional group of an alcohol. And that's the basic organic that all you need to be familiar with right now. And so we are done with this video.